Hello and welcome to video number 19 in this series, and in this video I'll review inequalities starting with linear inequalities. So in an earlier video we talked about representing inequalities such as x greater than 4 as representing all real numbers that are greater than the number 4. And we could think of this on a number line. If we have 0 on our number line here, and then 1, 2, 3, 4, then this inequality represents everything on this side of the number 4, not including the number 4. So the round bracket here indicates that we're not including the number 4. And we can also represent this using interval notation, as x belongs to the set of real numbers that are in the interval between 4 and infinity. And we're not including the number 4, so we've got a round bracket here, and we're not including the number infinity, so we've got a round bracket here as well. Other examples of inequalities would be x greater than or equal to 4. So we would write that using interval notation with a square bracket, and just a square bracket on the left hand side for the 4, because we're including 4 but we're still not including infinity. And then we could also go with a less than, so that would be x in the interval between minus infinity and 4, not including both endpoints. And then we could also have x less than or equal to 4. So that's going to be with a round bracket on the left side and then a squared off one on the right side. And then we can also have what's called a continued inequality. So we could have x in between, let's say, minus 4 and plus 4. And so this would be represented using interval notation as x belongs to the interval between minus 4 and plus 4. So next we want to move into solving inequalities. And that means if we have an inequality like the following, so 7x minus 4 less than or equal to 4x plus 5, we want to find all values of x that satisfy this inequality here. And so it's similar to solving an equation, except instead of an equal sign we have an inequality, but we employ the same methods. So we can add something to both sides, or we can multiply both sides by a number. So let me show you how that works in this example. So the idea, just as with solving an equation, is to get x onto one side of the inequality and just numbers on the other side. So let's have the x's go onto the left-hand side. So if I subtracted 4x from both sides, then that would cancel the 4x on this side. So we'd have 7x minus 4x. And then for the numbers, we want to get rid of the minus 4 on this side. So if we add 4 to both sides, then the minus 4 and the plus 4 would cancel on this side. So now we have 3x less than or equal to 9. And then finally we can just divide both sides by 3. Or we could think of that as multiplying both sides by 1/3, same thing. And we get x less than or equal to 3. And we would represent that using interval notation as x belongs to the interval between minus infinity and 3. And we're including the value 3. Just as when we're solving equations, when we're solving inequalities, it's a good idea to check that we've got the right answer. And one way to check is to pick a number that's in the interval that we ended up with. So in this case, if we picked something less than or equal to 3, so let's pick 3, then we could plug in 3 on both sides and make sure that the left-hand side is less than or equal to the right-hand side. So in this case, we would have 7 times 3 is 21, minus 4, so 17. And on this side, we've got 3 times 4 is 12, plus 5 is 17. And so 17 satisfies this inequality, because we've got 17 less than or equal to 17, which is a true statement. We have to be a little bit careful when we're multiplying both sides of the equation by a negative number, because what happens there is the inequality reverses direction. And we know that this is the case because, for example, if I say 1 is less than 2, which is true, if I multiply both sides of this by minus 1, we'd have minus 1 and minus 2, but minus 1 is not less than minus 2. Minus 1 is greater than minus 2. So anytime you multiply both sides of an inequality by a negative number, we have to change the direction of the inequality. So for an example of how that might come into play in solving an inequality like this, let's do 3x plus 2, and let's do less than 5x plus 6. And we want to solve this inequality, which means isolating x on one side, just have numbers on the other side. We're trying to find the solution set of x's that would make this inequality a true statement. So let's move the 5x over onto the left-hand side by subtracting 5x. And then let's move the 2 on the left-hand side to the right-hand side by subtracting 2. So now we've got minus 2x less than 4. And so now to isolate the x on this side, we're going to multiply by minus a half. And so if we multiply by minus a half, we're going to have x on the left-hand side, and 4 times minus a half would be minus 2. But because we're multiplying both sides by a negative number, we have to remember to change the direction of this inequality. So now that becomes greater than. So the solution set in this case is x in the interval from minus 2 up to infinity. And we could check if we pick a number greater than minus 2, let's say minus 1. Let's go back to our original inequality to make sure that we've done it correctly. So if we plug in minus 1 here, we would have 3 times minus 1 is minus 3 plus 2, so we'd have minus 1 here. And 5 times minus 1, minus 5 plus 6. We'd have plus 1 here. So minus 1 is less than plus 1. So it looks like we've done this correctly. So we talked about a continued inequality here, where we had x in between minus 4 and plus 4. We can also solve inequalities of that nature. So for example, switch to a different color. Let's do minus 1 less than minus 4x plus 3 over 5. And let's have a less than or equal to 3. So we want to find all values of x that would satisfy this continued inequality. And we solve it in a similar way to the way we solved the inequalities we looked at earlier, but we just have to remember that we've got kind of 3 pieces to worry about. So whatever we do to one piece, we have to do to the other 2 pieces. So for example, the first thing I could do here, I'm going to try and isolate x in the middle. So first of all, I want to get rid of that divided by 5. So I'll just multiply each piece by 5. So I'll have minus 5 less than minus 4x plus 3 less than or equal to 3 times 5, 15. And then let's get rid of the plus 3. So I'll subtract 3 from all three pieces. So we'd have minus 8 less than minus 4x less than or equal to 12. And then finally, let's divide by minus 4. So I'm dividing by a negative number, or think of it as multiplying by minus a quarter, multiplying by a negative number. So I have to reverse the inequality signs. So I'm dividing by minus 4 or multiplying by minus a quarter. So this is going to become 2, and then x in the middle, and then this one I'm dividing by minus 4, so that will become minus 3. And so typically the way you write a continued inequality is to have smaller numbers on the left and larger numbers on the right. So this is kind of written in reverse. So I'm just going to rewrite this as minus 3 less than or equal to x less than 2. And in interval notation, it would be x is in the interval between minus 3 and 2. And we're including minus 3, so we've got a square bracket on that side, and we're not including 2, so we've got a round bracket on that side. And let's just check. Let's pick a number inside this interval, say 0, and see if that satisfies the inequality we started with. If we had 0 plugged into here, we'd get 3/5, and 3/5 is in between minus 1 and 3. So looks like we've done it correctly. So at this point, pause the video and see if you can work through the next two problems that I'll put up and see if you can solve those inequalities. So that means find all values of x that satisfy the next two inequalities. So the first one will be 9x plus 2 greater than or equal to 5x minus 2. And then the second one, let's do minus 5 less than or equal to minus 2x minus 5 divided by 3 less than 1. Okay, so let's see how you did. So for this first one, we're going to try and move the x's to the left side, numbers to the right side. So first thing we can do is subtract 5x from both sides. So 9x minus 5x would be 4x. And then we'll try and move the 2 over onto the other side by subtracting 2. So minus 2 would be minus 4. And then we'll divide by 4. So we'll get x greater than or equal to minus 4 divided by 4 would be minus 1. And in interval notation, that would be x is in the interval from minus 1 up to infinity. And we could check. Let's pick a number in this interval to check with. Let's pick, say, the number 1. 9 times 1 is 9, plus 2 would be 11. 5 times 1 minus 2 would be 3. So yeah, 11 is greater than or equal to 3. So that's a check that we've done this correctly. Doesn't mean for sure we've done it correctly because it's just one value, but at least it gives us some reassurance that we haven't made a silly mistake. For number 2, so first thing, multiply all three pieces by 3. So I have minus 15 less than or equal to minus 2x minus 5 less than 3. And then next, let's add 5 to all three pieces. So minus 15 plus 5 would be minus 10 less than or equal to minus 2x less than 3 plus 5 is 8. And then we'll divide by minus 2. And remember, if we're multiplying or dividing by a negative number, we have to switch the directions of the inequality signs. So I'll just do that first so I don't forget. And then I'll divide through by minus 2, so we'll have x left in the middle. And minus 10 divided by minus 2 would be 5. And 8 divided by minus 2 would be minus 4. And then I'll just write this in the usual fashion, so with the smallest number on the left, the biggest number on the right. So minus 4 less than x less than or equal to 5. And so in interval notation, that would be x is in the interval between minus 4, and we're not including minus 4, so we've got a round bracket there, and then plus 5. So we've got a squared off bracket there. And last step is just check with a number in this interval, say 0 is inside this interval. So let's plug in 0 here. We'll have minus 5/3, and minus 5/3 is in between minus 5 and plus 1. So that provides some reassurance that we've done this correctly. So that's it for this video, and in the next video, which is the last video in this series, I'll stay with inequalities, but I'll look at inequalities that involve polynomials, rational expressions, and absolute values.